Hi, this is Mr. Elmhorst with the help video for the Pythagorean theorem homework. So we got a tree leaning up against the side of the house. The bottom of the tree, 15 feet from the house. The tree is 20 feet. How tall is the house? So the question mark is how tall is the house? We could put X in there. So bottom of the tree is 15. And we got this tree leaning up against the house. So we are trying to, and that is, the tree is 20 feet long. So how tall is the house? We're going to use the Pythagorean theorem where we square the two legs. The two legs have the right angle. And if we add those, it's going to equal the square of the hypotenuse. So we have x squared plus 15 squared equals 20 squared. Now, I'm going to put the variable on hold for right now. And we're going to subtract the 15 squared. So 15 times 15 is going to be 225. And 20 and 20 times 20 is going to be 400. So we're going to subtract 225 from both sides, and we're going to subtract 225 from 400. That's going to cancel, and we're going to be left with 175, and we need the square root of both sides. So 175 is going to be between the two perfect squares. So we have 169 and 196. So this is going to be 13 squared and 14 squared. So we're going to find the difference from 175, and that is 6, and find the difference from 175 to 196. I believe it's actually the difference for here, from 169 to 196. So that's going to be 33. So the square root is going to be 13 and 6 out of 33. And that estimates to be about 13 and 13.21 or 13.2. Yeah, I had a slight correction to make here. The difference from 196 to 169 is 27. So that will give us the correct estimation of 13 and 6/27, which is going to be 13.22. Okay, we've got a flagpole casting a shadow. How far is it to the top of the flagpole from the end of the shadow? So if you are ever so inclined, you can draw a little flagpole. And how far is it from the top of the flagpole to the end of the shadow? So here's your question mark. How long is it? And we can represent that with X. The 20-foot tall and 12 foot long shadow. So we're going to square the legs, add them together, and that will equal the square of the other side. So we fill out our formula. We have 20 squared plus 12 squared is equal to x squared. Yeah, 400 plus 144, which is equal to x squared. Put these together, so we got 544. And we're going to take the root of the square to cancel it. And so we do the square root of each side. And we need the square root of 544. and we're checking our chart. So 544 is between the square of 23 and the square of 24. So the square of 23 is going to be 529, and the square of 24 is going to be 576. So we find the difference between 44 and 29. That's going to be 515. We have 15, and then we find the total difference between 529 and 76. We got 76 minus 29. So it's 15 out of 47. And now if we multiply those by 2, that gets us close to 100. So it's going to be right around 30, so 23.3-ish something. Wheelchair ramp is 10 feet long. So we got a wheelchair ramp. The ramp is 10 feet. The ramp sits on top of a 2-foot platform, so it's sitting over here. That's 2 feet. How far is the end of the ramp? From the bottom of the platform. So we have x. So we're going to square this side, and then we're going to square the first leg, square the second leg, and we're going to set that equal to the square of the hypotenuse. So you have 2 squared plus x squared is equal to 10 squared. So you have 4 plus x squared is equal to 100. Subtract 4 from both sides. So you have x squared, which is equal to 96. And we're going to do the square root of that. So the square root of 96 is going to be between 100 and 81. So we're going to find the difference between 81 and 96. And real quick, that's going to be the square of 9 and the square of 10. So our answer is going to be 9 point something. 96 minus 81 is going to give us 15, and 81 to 100 is going to be 19. So 15 out of 19, both of these, if you multiply by 5 times 5, that's going to give you close to 100. So 15 times 5 is going to be 65. So this, as a rough estimate, is going to be about 9.5 times, so 9.66 maybe. And you can use a calculator to verify that, the square root of 96.